Okay, these are the notes for Unit 7, Section B. We're going to look at a couple properties today, the product property and the quotient property. And the product property is basically this. If you have two bases that are the same, so we have a to the m and a to the n, all you have to do is add their exponents if you're multiplying those bases. So this real simple example here, you'll notice we have 2 to the third times 2 to the fifth. We take that 3 and that 5, we add them together, and we get 2 to the 8th. So let's look at why that's true. So I expanded these just to save a little bit of time here, but the product rule here states that if I'm doing x to the fourth times x to the third, I should get x to the seventh, right? But why is that? Well, if I look along here, here's my x to the fourth, so I have 1, 2, 3, 4, and then we have 4 more x's, and if we're multiplying all of those x's together, then that should give me the repeated x to the 7th power, right? On the next one, m to the second, m to the fifth, you can see all, my 2 purple m's, my 5 purple m's, you multiply those all together, and you get m to the 7th. And on that last one, we have x to the fourth, y to the third. Now we have to be careful here. None of those are the same. So there's really nothing we could be doing with this one. It just goes back to x to the fourth, y to the third, right? So let's just use our product property here and do these real quick. You can do them with me. If you feel like you're okay, you can work ahead a little bit. Now, one thing that's important to remember is, and I'm doing this on all these examples, is if I don't have an exponent, there is a 1 there. So when I combine these two, x to the fourth times x to the first, that's going to be x to the fifth. M to the second, m to the 11th, that's going to be m to the 13th. And then x to the fourth, y to the third, x to the second, y to the first. I want to be careful here. My x's, we have a 2 and a 4. So that's x to the sixth, and then y to the third times y to the first is y to the fourth. All right, so what I want you to do right now is on the next 6 examples, I want you to work your way through those. Those are just the quotient property, so remember to add the exponents together. So we'll pause the video and take a look at the next 6 and unpause it when we're ready to go. Okay, so let's take a look at the first 2, right? You're simply adding those exponents together. Don't forget there is a 1 there. That's why that's x to the 9th and not just x to the 8th. We slide over here. We have a few more things, right? So 4 plus 1, 4 plus 1 is x to the 5th, and then y to the 4th is just y to the 4th. Here, we have 2 to the 8th. You can leave it like that, or you can actually plug those into, you can do 2 to the 8th and get 256. Sliding on down, we have a slightly different notation. We're still just multiplying number 5 together, even though it looks a little bit different. So we're going to add the exponents. There is a 1 here, so x to the 7th, y to the 7th. Now, the big one here, check your work. A lot of people are going to look at this 2 and 6, and they're going to be thinking of the quotient property, and they're going to add those 2 numbers together. But you're actually doing, you can see I have it rewritten below. If I reorder these, because this is multiplication, you're actually doing 6 times 2. So that should be 12x to the 5th. That's a fairly common mistake there. All right. Now, these last few, we're not going to do all of these, but these are worth talking about here. So again, when you're multiplying things together, here I'm doing 8 times 5, which is 40. And then I'm adding the bases. This is where it starts to get tricky, where sometimes we add numbers, sometimes we multiply numbers. Now, C is the same. We want to look at this. I can think of this like this. If I asked you to do x to the third, x to the fifth today, hopefully everybody would tell me that that is x to the 8th. Now, right now, I do not multiply the 8 and the 8 together. I have 3 8s and I have 5 more 8s. So this is going to be 8 to the 8th power, not 64 to the 8th power. So think of those as like, how many 8s do you have together? You can expand it if that helps you think of it. All right. Now we're going to move on to the quotient rule here. So the quotient rule is if you're dividing the bases, you subtract the exponents, right? So you can see this first example, pretty straightforward, right? we have 2 to the 5th over 2 to the 3rd. 5 minus 3 is 2, so this is 2 to the 2nd power, right? We're using that principle. Now, we're going to expand here. So you can see on A, I have 4 x's on top, and I have 3 x's in the bottom. A lot of times, we're just going to think of this as canceling, right? These guys cancel these guys out, right? So we got pairs, pairs, pairs. So we're left with x on top, so that would be x to the 1st. So x to the 4 minus 3 power is x to the 1st. You do not need the 1 there, but I'm just doing that as like a little placeholder. This is a little bit trickier again. See how these guys pair up and these guys pair up. Now here I'm left with 3 m's, but those m's are in the denominator, and I cannot just leave this like half fraction here. I do need that placeholder of a 1 on top. All right. This one's a little tricky because if you use the quotient rule, you're going to get m to the negative 3, but we want our exponents to be positive. Okay, and we'll talk about negative exponents. And then this last one, nothing cancels out. And okay, that's fine. Nothing cancels out. We just have to put that back together, and it's just going to stay x to the 4th, y to the 3rd. All right, so let's do these without expanding. This one, again, we're going to get x to the 3rd, right? Because 4 minus 1, there's like a 1 there. This one, if I do this straight up, it's going to be 2 minus 11, right, which is going to give me a negative 9. Right now, this is okay for an answer. Eventually, we'll talk about how to turn this into a positive, but we don't have the negative exponent yet, so we'll talk about that in a little bit. And then the last one, again, we have 4 minus 2 for the exponent of x, so it's x squared. And then we have 3 minus 1, so that would be y squared. All right, so for the U-tries, take a few minutes, try these on your own. We'll pause the video while you're working and unpause it when you're done. Okay, so first ones, you're just subtracting the exponents, right? A squared, then I should have x to the 7th. On this one, we'll change this a little bit. For today, let's just call this x to the negative 6, because 4 minus 10 is negative 6. And then on number 4, be careful here. You don't actually cancel out those 2's, right? All you're doing is 15 minus 3, so that's 2 to the 12th. You could actually put that in the calculator if you want, but right now we're more concerned with having the right exponent. And finally, these last few, you can only cancel the x's. This one, if we wanted to do this, the best way we would write it today, right now, is you would have x to the negative 4th, y to the 3rd. All right, and the last one, we are reducing. You should not have a 4x to the 5th. You should have a 3 because 6 divided by 2 is 3. So remember, we are reducing. So the exponents are the only things that are going to get subtracted, not the numbers in front. The coefficients, we reduce just like fractions. All right, now moving on to these things. Again, this will kind of reiterate what we were just talking about. So here, when I look at 18/6, you could divide those both by 6, and you would get 3 over 1, and then we would subtract those exponents. 14 minus 5 is 9, so this is 3m to the 9th. And then looking at this last one, again, you're doing 8 to the 13 minus 2 power. You do not cancel out the 8s. This is just 8 to the 11th, which is a fairly large number. We'll leave it there. We're not going to go any further with that one. All right. Now, these scary ones. We're going to focus on challenge number 2. We won't do challenge number 1 today. What happens when I have multiplication and division in the same problem? So I think the easiest way to do this is to just go across, right? So we're going to take this one at a time. So I'm going to ignore the bottom of the problem. If you were asked to multiply these, you would get 18 x to the 9th. You would add those exponents together, y to the 7th. In the denominator, now we can look at the denominator. We would have 2. We have x to the 1st and x to the 1st, so that's x squared. And then we have y to the 4th. Okay, so I took a very complicated problem, lots of things, and now we've kind of narrowed it down, and we just have the quotient property. That 18 over 2, 18 divided by 2 is 9. Then we have 9 minus 2, so x to the 7th. And then 7 minus 4, that's x to the 3rd. So if you have problems where you have multiple things going on at once, We want to try to simplify it into like one single fraction. Then we can use our quotient rule. So usually you want to use the product first and then the quotient rule. So the homework for this is worksheet B. I'll be there to answer questions in class tomorrow. Thanks for watching.